Let's now look at the enthalpy of formation. So this would be symbolized by delta F H, and then standard state, standard molar enthalpy for the little circle at the top right there. So this would be the standard enthalpy of formation, and this would be defined as the enthalpy required to produce 1 mole of a substance at standard temperature and pressure, or standard conditions. So that's typically 1 bar, and then STP usually is 273 Kelvin. Sometimes you'll have SATP as well, which might either be 293 Kelvin or 298 Kelvin, depending on your source, so check your source. But basically, we're doing this, we're creating 1 mole of a substance, and the key is that it is from elements, from their elements in their standard states. Okay, so this means that for the standard formation enthalpy for an element like O2 gas, H2 gas, solid carbon, solid lithium, helium gas, the list goes on. So that means that the enthalpy of formation, not of reaction there, of F equals 0 for elements in their standard state. So let's do an example here. Let's write the equation for the standard enthalpy of formation of a mole of glucose. So we're going to have 6 carbon, solid. Standard state of carbon would be just solid graphite, plus 6 moles of H2 gas, standard state for hydrogen being H2 gas, plus 3 moles of O2 gas, standard state for oxygen, O2 gas, and that is all going to C6H12O6 in the solid state, so just crystallized solid glucose there. So for this reaction, our enthalpy of formation for a mole of glucose is going to equal minus 1271 kilojoules per mole. So it's very, very favorable relative to the elements in their standard state to form glucose. You're going very much energetically downhill. This would be a very exothermic reaction. It produces a molecule which is much more stable and is releasing heat to the surroundings as a result. Okay, so just so we're clear on this standard state for elements, let's talk about a few more elements in their standard states. So for most elements, it'll just be them in a solid state, like say solid lithium, sodium. Most metals would just be the metal in a solid state. For your noble gases, it would just be helium gas, argon gas, neon gas, etc. But the exceptions to these are the 7 elements which traditionally exist as diatomic gases in their standard state. And those would be H2, N2, O2, fluorine, chlorine, bromine, and iodine. So it's hydrogen, nitrogen, oxygen, and then the halogens. So those 7 exist as those 7 exist as diatomic gases. Let me put the 2 down there. The noble gases exist as monatomic gases, and pretty much everything else is going to exist as a solid for its standard state. So the enthalpy of formation for any of these compounds that I have listed here would be 0 because these are elements in their standard state.